تلخيص ستيلز. Steels are less than 1.4% carbon. steel alloys عندنا PP MMNM. PP MMNM. P plain carbon. P التانية plain carbon but resulfurized. M manganese. M molybdenum nickel molybdenum بس higher percentage of molybdenum. XX هي percentage of carbon. To produce pig iron we use Fe2O3 plus 3CO and we get 2Fe plus 3CO2. To remove C in pig iron, we do 2Fe plus O2, it gives us 2FeO. From there we say FeO plus C, we get CO2 plus Fe. We get CO plus Fe. Electric arc furnace is used to produce carbon steel alloys and alloy steels. We use 80% of recycled ferrous scrap or 80% recycled scrap. عندنا ستيلز الوصف الكربون بتاعها بنقول PH PHT PT. فده plain بعد كده HSLA بعد كده plain بعد كده heat treatable بعد كده plain بعد كده التول. وبنبدأ من لو كاربون أقل من 0.25% من 0.25 to 0.6% ومن 0.6 to 1.4% weight of carbon. وبعد كده عندنا الهاي alloy عندنا stainless على اليمين وعندنا التول على الشمال. In iron carbon we can get any desired property by altering or by changing the microstructure through surface hardening, heat treatment and deformation. من تحت الفوق من عند حوالي 1200 درجة عندنا austenite بعديها اللي تحته الفيرايت ألفا بعد كده اللي تحته البيرلايت بعد كده أخيرا عندنا السيمنتايت على اليمين خالص اللي هو 6.67% carbon. Heat treatment begins with austenite. Maximum solubility of austenite is 2% at 1147 degrees. Ferrite is softest, it's BCC, it's dissolved in BCC, it's stable below 910 degrees, maximum solubility is 0.025%. Perlite is a mixture of ferrite and cementite. Eutecticoid, perlite is eutecticoid, it contains 0.8% carbon and it's formed at very slow cooling. Cementite is a crystal, its crystal structure is orthorhombic. Labradite is a eutectic mix of austenite and cementite. It contains 4.3% carbon. بعد كده في continuous cooling transformation diagram عندنا الثلاث حاجات الفيرايت فوق على اليمين بعدها البينايت تعتبر في النص وبعدها المارتنسايت تحت خالص. كل ما يعني لو احنا بطأ خالص ودرجة الحرارة بتنخفض ببطء بيكون عندنا الفيرايت. لو أسرع شوية بيكون البينايت ولو أبطأ بكتير أو لو أسرع شوية بيكون البينايت ولو أسرع بكتير بيكون المارتنسايت. المارتنسايت هو أقوى حاجة عندنا ممكنة والمارتنسايت هو super saturated. الكربون because of the very cold of the very fast cooling carbon can't diffuse out of martensite, so it becomes black, it becomes very strong and it becomes super saturated. Austenite becomes martensite when undercooled. عندنا plain carbon steels وأعلى حاجة فيهم بتكون أكتر من 0.6% carbon. عندنا low alloy steels اللي هي أقل من 8% alloying element. عندنا high alloy steels اللي هي أكتر من 8% alloying element. وطبعا الكربون بالنسبة لللو alloy ما يزيدش عن 1.4% weight. عندنا اللو كربون بيكون شبه رمادي مع بعض النقاط البسيطة من الكربون. الميديوم كربون بيكون أبيض والهاي كربون بيكون أغمق بكتير خالص. Plain carbon steels they have low hardenability and low strength. Alloy steels they have good hardenability, good strength. They can be used at high temperatures as well, so it's much better. هنا عندنا بعض effects of alloying element. Low alloy steels they have to be less than 8% or equal to 8% of the يعني of the steel material. Boiler steel tube is the most widely used low alloy steel. High strength low alloy steels, also named as microalloyed steels. They use titanium or niobium for grain refinement and precipitation. Low alloy steels for high temperature properties. They're used in steam turbines or electric power generation, and they contain nickel, chromium, molybdenum. Low alloy steels for improved corrosion resistance. They have copper, nickel, and chromium, and are called weathering steels. Low alloy steels with formability, they're combined with carbide and nitride forming elements such as titanium and columbium. And they have interstitial elements of carbon and nitrogen. Bake hardenable low alloy steels, they increase strength during paint baking cycle. Bake hardenable low alloy steels, they develop compounds that precipitate at paint baking temperatures to increase the hardness of the steel. Dual phase low alloy steels, they have 10 to 20% martensite. They're used where yield strength is increased by the forming process. Corrosion resistant stainless steels, they are at least 10% chromium. Austenitic stainless steels, they have microstructure of austenite at room temperature, so they are non-magnetic. Ferritic stainless steels, they have 10.5% to 27% chromium, and they lack high nickel content. Precipitation hardening stainless steels, they have nickel and chromium. Precipitation hardened stainless steels, they are chromium, nickel, and they can either be ferritic or martensite. Duplex stainless steels, they have ferrite and austenite and a high percentage of chromium, and they look like white lines, white, and then we have gray lines. Heat resistant steels, they have high chromium and molybdenum, and they look quite dark. Tool steels, they have molybdenum and tungsten. Austenitic manganese steels, they have between 11 to 14% manganese, low percentage of carbon, from 0.7 to 1.45% carbon, and they are good. They have good toughness, good ductility, and they have good wear resistant. Ultra high strength maraging steels, they're the strongest as they are martensitic and they are aged. Magnetic steels have alnico, which contain 20% cobalt and 14% nickel. Non-magnetic steels, they have 14 to 30% manganese. Non-magnetic steels can be used for cryogenic applications. Low thermal expansion steels, they have 36% nickel and 4 to 6% cobalt. High thermal expansion steels, they have a high percentage of nickel, about 29%, and a high percentage of chromium. Electric steels are used for electric motor laminations, and they contain silicon. We have three types of automotive steel grades: low strength steels, conventional high strength steels, which is HSS, and AHSS, which is advanced high strength steels. HSS is bake hardenable, AHSS has plasticity. For low strength and conventional steels, we have mild steel, which has ferritic microstructure, good for drawing. We have IF, interstitial free steels. They have ultra low carbon levels, and we have bake hardenable steels. They are designed to keep the carbon in solution, and they have a ferritic microstructure. And then we have HSLA, which is high strength low alloys, and they have and they increase the strength by microalloying. Anisotropy means basically the strength is dependent on the direction of the grain, which is calculated by ratio of the width divided by the ratio of the thickness. ومثال كده الخشب. ال R value is also called Langford value. High R equals good formability. High R equals high formability. N is work hardening exponent, which measures how quick the material gains strength when deformed plastically. Equindex gives us the total performance of the material. It's calculated by UTS times EL, which is ultimate tensile strength, times uniform elongation. According to Equindex, we have the best to be AHSS and we have the worst to be MNB, as it has 10% GPA, and AHSS is the best because it has 60% GPA. عندنا فيرايت مارتنسايت دول فيز والتريب. الفيرايت هو رمادي، المارتنسايت اسود بابيض غامق. الدول فيز هو يعتبر اسود خالص، وبعض الرمادي برضو الغامق مع الحدود بيضة، والتريب بيكون الوان. TWIP has high strength and high ductility. In addition, it has high manganese content. Steel naming: GB for China, Germany DIN, Russia Ghost, Spain Uni, France AFNOR, Italy UNI, Sweden SIS. Steel mainly used for construction at 60% and machinery at 20%. Mainly AHSS is used in automobiles, and 50% of the weight of the car is steel. السلام عليكم، كنت معكم أحمد خالد.